In today's video, we're going to be reverse engineering this small little mini tripod that I picked up. Printable Science presents a 3D printed, reverse engineered mini camera tripod. And as you can see, it's black. What you can't tell perhaps is that it's got aluminum legs, some plastic in it, and you can adjust the feet like so by pulling it out, and they stay where they are. And you can remove the camera, and it has the standard 1/4-inch thread on it. There you have it. So here's two examples of what we printed, and as you can see, they're fairly close to the real thing. And let's take a look at this existing bought one. So as you can see, the other feature it has is this screw bolt there, and you can turn that, and then this allows you to pivot the ball inside the retainer at the top and put the camera just basically any direction you feel like it. So as you may have seen as I was showing this off, the legs are friction fit and they can be pulled off. I could put some glue in there, I guess. And no, they don't all come out. So some dimpling that was provided there to crimp it to the post in the tripod head obviously has come loose on that one. So that's basically what we're looking at. So how do you take this apart? Well, it's a good question. First of all, you can see that this has the plate that the camera sits on. It just unscrews, and then there's a threaded part that fits into the ball at the top. And there's just a single Phillips star there, and if we take that off, then you can see that we've got the legs into a leg plate, and the leg plates just sort of sit in there, and when it's fastened in, the leg plate pushes down and prevents the little extrusions there from falling out once the plate is in place. This kind of flap bolt is fun, but it's a little bit of overkill and difficult to engineer in a small part on a FDM 3D printer. So what can we do? Well, first of all, as you know from watching this channel, one of my mottos is if you can 3D print it, then 3D print it, and try to avoid as much as possible any exterior kind of or bill of materials beyond just your 3D printer and the 3D printer filament. So we need some parts. We need some exterior legs, 3 of those, to match the exterior leg of the prototype or the real one, and we got those printed off. We need some interior legs, so we printed off 3 of those. And for those of you who are counting, you can see I got a little bit trendy here and did a level change from black filament to silver filament to sort of, in a sense, mimic the original design. So you can do that as well. Then we have our tripod plate, which is a somewhat different design from what we've got here, but that'll become clear while we've done that. And oh look, I've printed off 2 of them. Well, which one should we use? I can't. Well, either one will do. And then we have our tripod plate. And then we have our tripod head. And then we have, still on the brim, our ball. And then we have a thread. Now, as I pointed out to you, the legs on the original design have these protrusions. Let's see. Can you see that? they have these protrusions for fitting in a channel in the tripod plate, and that's kind of hard, if not impossible, to do on the 3D printer. As you can see, the exterior leg that we printed just has a hole there rather than a protrusion on either side, because we would have overhang if we had a cylinder coming out at that point, or any sort of round protrusion. So what we're going to do is we're going to use small little pins, which will, God willing, fit in there, and then secure to the tripod plate by pushing them through. So let's see what we can do there. You always might want to print a few more than you need, because you sometimes get printer failure on small parts like that, but let's see how it goes. Okay, and then finally, for rather than the fancy little flop screw there, we've just got a single thread for that. Now, we also have this fancy little custom spanner, which you may or may not need according to how well your assembly goes. So the most difficult part of the assembly is putting the legs in the tripod plate, and let's give that a go. Now you can see that there's, or maybe you can't, let me see if we can make that show. There's a hole for the axle to go through, and then an indent, and that primary purpose is to allow you with a pair of pliers to grip and squeeze them together without the pliers popping off. So just going to pause the video here and run off another set and make sure that the correct STL for the pins is in the files that I post. Okay, so we've printed off a half dozen more of these things, and got a better printing job, so I'll just peel off 3 and hope that's all we need. We just take a pin and find a hole and push it in. That's got it nice and secure. I did say this was the hardest part, right? Looks good. Okay, so there we have our 3 exterior legs, and we're good to go. So now we can take our ball and thread in the spike there, or I should say the screw. bolt. And if you want to make things more permanent, you can just put a dab of glue in there before you start. Then we take this part of the tripod. And let's see, we've got a little bit of stringing going on there. We can just pull that off. And there is a bit of a thread on there. So we just drop this in, and as you can see, that fits around there like that. And then we just thread this in. And if you want, this is where you can use our fancy spanner. And those three little posts there fit in there, and you can get some traction there to tighten it up as much as you can or as you want. And there we go. So there we have the three legs of our tripod. And now all we do is put the plate on which the camera sits, and then we put our thread in here, and that'll secure it at the angle we want. So there we go. Now, here comes the most inventive part of this reverse engineering. As I demonstrated to you with this has obviously some sort of bushing in here that that provides friction, that kind of holds it in place, and we just don't have the tolerances for that kind of precision fit, and also it doesn't really work out really well with plastic. So what do? We've got these tripod feet, and you know, they'll just fall out. Except what we've done is we have made these slightly, well, it's not going to show here because it's so different. It's not an exact circle, it's a bit of an ellipse. So what that means, and there's a corresponding ellipse with a slight bit of tolerance, so that in this angle, it does just slide in as long as they're aligned. But all we have to do is spin this, and the larger diameter of the ellipse rubs against a friction fit of the exterior tube, and it's not going anywhere. So there we have it. And we have our reverse engineered mini tripod. Voila. Doesn't get more exciting than that, right? Now, as you can see, we can just put our camera on our 3D printed tripod. And it holds it quite well. We can use the nut so that frees up the ball to put it where we want, tighten it up, it's not going anywhere. We can put the ball down, gives us even more movement there, and there we have it. Now you might kind of ask yourself, has this got the same strength as the metal one? And the answer is no, probably not. And I wouldn't try it on a Leicaflex, but for something like an iPhone, or, well, actually, iPhones are worth more than real cameras these days. But it's got a, well, in a sense, it's got more holding power than the store-bought metal one. So Can we try any taste test? Let's see. Let's see if I've got anything heavy around here. One sec. Okay, so let's give this a try. This is 5 kilograms, 10 pounds. Will it hold that? So as you can see, it's got the strength for 5 kilograms, 10 or so pounds. Should get you through your most challenging mini tripod requirements. Now I should point out there is one design flaw in the current design or current reverse engineering, and that is, as I pointed out to you, in the original, we have these legs which are held in place or made to be sticky by virtue of a bushing, but there's also some sort of ring that prevents them from coming out. Now, we overcame the problem of getting these to stop where we want by just twisting two ellipse-shaped cylinders against each other, and that gives a friction fit which prevents them. But if they're falling freely, or I should say if they're sliding freely, then it can fall out. So if you've got any ideas how that problem might be addressed, leave some words to that effect in the comments below. So there you have it, your own 3D printed, reverse engineered mini tripod with a capacity for over 10 pounds or 5 kilos of weight. Let's face it, there's nothing to hold you back now. With mini tripods like this, you'll burnish your golden reputation with your friends, plunge a metaphorical sword deep into the hearts of your enemies, and earn 2.7, or I should say 12.7 virtue points for towards your divine admission for each mini tripod you print and assemble. Check out the description below for the link to download the STL files you'll need for this project, and thanks for watching. And as always, we invite you to visit our website at printablescience.com, where all the science that fits we print.